Hi everyone. In this video, I am going to explain about Quicksort. So in this Quicksort, in order to sort the elements, we are following few steps. The first step is select pivot element. So what do you mean by this pivot element? Pivot element is nothing but an important element. Among the given set of elements, we need to select any one element as one element we will select. That element we call as a pivot element. So generally we can select any element as a pivot element. There is no rule that we need to select that particular element only. We can select any element. But to have the uniformity, generally we are selecting the very first element as a pivot element. First element we are selecting the what? Pivot element. That is the first step. Second step, so we are doing left scan. We are doing what? Left scan. That means we are moving from left to right. So that means suppose this is the given array, from left side to right side we are moving. Okay, that is what left scan. So during left scan what we will do, we are looking the what? Lesser element. We are looking for lesser element. So, and then after stopping the left scan, so when to stop left scan, whenever we will find, we'll stop this left scan, whenever we find greater than or equal to the pivot element, we will stop the left scan. Okay, so during this second step, we are doing the left scan. During left scan, we are looking for lesser elements. Whenever we find greater than or equal to the pivot element P, we will stop. After stopping the left scan, then we are performing right scan. Okay, during, that means right scan, we are moving from right to left. Suppose this is the given array. So from the right scan, we are starting from here, and then we are moving like this from right to left. This is what we are doing in the third step. And during right scan, we are looking for the element greater than the pivot element. Okay. Suppose if you find lesser or equal, then we are stopping. That means we are stopping the right scan whenever we find element lesser or equal than the pivot element. After stopping both the scans, then what we are doing? Then we are checking what? I and J. What is I and J? So in order to do the left scan, we are using what? I as an index, and to make right scan we are using index J. Okay, so index I we are using for left scan, index J we are using for right scan. So see again, I and J are the positions, whereas P is an element. Okay, so after stopping both left scan and right scan, so we will check the positions I and J. Suppose now the possibility is what? If now I is less than J, if I is less than J, so then what we will do? We will swap ith and jth element we are swapping. Okay, suppose after stopping both the scans, we will check the position I and J. If I is less than J, we are swapping ith and jth element. Suppose if it is not less than J, then what is the possibility? If it is not less than J, obviously I may be greater than or equal to J. So in this case, we are swapping what? Jth element and pivot element. Okay. So if I is greater than or equal to J, we are swapping I jth element and pivot element. After swapping this one will stop, but if you swap ith and jth element, then again we are continuing this left scan and right scan both. Okay, so first step to select the pivot element, generally we are selecting the first element as the pivot element, then start left scan. During the left scan we are looking for the lesser element. We will stop left scan whenever we will find the greater than or equal to pivot element. Then after stopping left scan we will start right scan. During the right scan, we are looking for the greater element. We stop right scan whenever we will find lesser than or equal to element. After stopping both the scans, then we will check the I and J. So then if I is less than J, we swap ith and jth element and continue these two scans. Suppose if I is greater than or equal to j, we swap jth and pivot element and we stop this process, and that is in the first pass or first cycle or first round. After that, again we need to apply the same process to the left subarray and as well as right subarray. Okay, so this is the general procedures or general steps what we need to follow in order to sort the elements by using quicksort. Okay, now the basic principle of quicksort, what the quicksort is. So given this array, so given this, let us take some array, some element, okay, some 0 to 1, 2, 3, so like n minus 2, n minus 1, this is array. Now this array, now we need to split in such a way that, so pivot element sits at some position and towards left of this pivot element, all the elements are lesser than or equal to pivot element, and towards right to the pivot element, all the elements should be greater than or equal to pivot element. This is the basic principle of quicksort. Okay, so now once we partition the array into two sub-arrays, okay, so now pivot element comes and sit in the final position in such a way that if all the lesser than element we are keeping one side, greater element we are keeping one side. This is the basic principle of idea what it is using. So in order to keep lesser elements, we are doing what? Left scan. So to make two, among the given set of elements, to segregate, to separate lesser elements, we are doing left scan. So similarly, in order to separate greater elements, we are using what? Right scan. So left scan is used to segregate lesser element, right scan to segregate greater element. So after that, so in between those two, we are placing the pivot element. So the way we place the pivot element, that is the split position. In that position, we are splitting this array. Okay, hope you people understand a little bit. Now we'll take one example. So with that example, we'll understand this more detail. Now I took these elements for sorting. Let us say 5, 8, 3, 6, 2, 8, 1, 7. These are the elements I need to sort. What is the first step? We need to select the pivot element. So which element we need to select as a pivot element? Generally, we are taking the first element as a pivot element. So I will mark, okay, this is my what? Pivot element P. First step is over. Next what? After selecting the pivot element, second step is to consider what? Left scan. So for left scan, what is the variable we took? For the index what we took is I. So where we have to start? From the next position to the pivot element. Where we start the pivot element? From this next position, I am taking the I. So remember, I and j are the index. I and j are the index. Now I is 1. So ith element is 8. Now I started left scan. During left scan, we are looking for what? During left scan, we are looking for lesser elements. So I check. This ith element is lesser than the pivot element? No. So we find what? Greater element. We stop left scan. After stopping the left scan, what to do? Right scan. So right scan, generally we are starting from what? From the last position. Okay, now j is 7. Okay, position 7. Okay, so now during right scan, we are looking for what? Greater element. So now jth element, this is greater than the pivot element. Yes, this is greater than the pivot element. We will continue. That means we will move from, right to left. So from this right to left, we are moving. So decrement j. J7 now come to this position. That means j we are decrementing. Now again check. So again, the jth element is greater than the pivot element? No. So since it is not greater, lesser than, we will stop. After stopping both the left and right scan, what to do? Check I and j. Now check. I value is what? 1. J value is what? 6. Now is I is less than j or greater than j? I is 1, j is 6. So less than j. I is less than j. So what to do? Swap ith and jth element. If you swap ith and jth element, see, these two elements will be swapped. So here 1, here 8. So remaining element as it is. Okay. Now this is what we selected as a pivot element, and this is where we stopped earlier what? Left scan. See, after swapping ith and jth element, what to do? Again we need to continue these to repeat left and right scan. Now again, earlier we stopped left scan here, so again so now new ith element is lesser, because in left scan, again in the left scan we are looking for what? Lesser element. So ith element is lesser, true. Okay, now that means you can what? Go forward, that means left to right. So that means I am incrementing I am going to the next position. Okay, next again, ith element is lesser than the pivot element, yes. Again continue, ith element is lesser than this pivot element, no. First ith element is greater, so we will stop left scan. Left scan we are stopping whenever we find greater element. So ith element is greater, we stop. After stopping the left scan, what to do? We have to start right scan. Right scan, earlier I stopped this position. First from this position only I will start. Okay, now during right scan we are looking for what? Greater. Jth element is greater than the pivot element. Yes, 8 is greater than the pivot element. So continue right scan, decrement j. So now again, jth element is greater than the pivot element. Yes, continue. No, jth element is greater than the pivot element. No. So when it is not greater than, that means whenever we find lesser than or equal to pivot element, we will stop. Okay, and stop the right scan. After stopping the right scan, what we need to do? We need to check I and j. Now I is what? See, I'm not at the positions here again. I position is 3, j position is 4. So 3 is less than 4. That means I is less than j. So swap ith and jth element. So ith is 6 and this is jth element is 2. So these two I am swapping. So these two becomes swapping. Remaining elements as it is. Okay. So now this is what we selected as a pivot element. So next what? So earlier we stopped what? Left scan here, because after that again we have to continue right and left scan. So now this is left scan. So during left scan we are looking for what? Lesser element. Ith is lesser element, true. Continue scanning. Ith element is lesser, no. I stopped here only. After stopping this, we need to check right scan. Right scan, earlier I stopped here. So again from there I will continue. Now jth element is greater. Yes, jth element is greater than the pivot element. Continue. So j comes here. Now jth element is greater than the pivot element. No, I stopped here. After stopping both the scan, what you have to do? Check I and j. Now if you see, I value is 4, j value is 3. R, that means I is greater than j. R, see, I started from here, j started from here. So now after that, see now I and j are crossed over each other. See, I is crossed over j, R, j crossed over I. So whenever these two crossed over, that means I greater than j, I am swapping what and what? Swap jth and pivot element. Jth element is 2, pivot element is 5. So these two elements will get swap, remaining elements as it is. Okay. Now after that, if you observe, this is my pivot element and see, this is my what? Left subarray, this is my right subarray. If you observe, what is the basic principle of this quicksort? So we need to place all the lesser elements towards left of the pivot element, and we need to keep all the greater elements towards right of the pivot element. See, we did that. See, all the elements greater than 5 are one side, lesser than the 5 are we kept at one side. So this did. Now this is my what? This is my what? Split position. This is my split position. That means now this array I have split it into what? 2 subarrays. So this, and I splitted this array in the position 3. In the position 3 I split it. Okay. Now I got 2 subarrays. Now we need to separately, we have to sort again this left and right subarray. So I'm taking the left subarray first. Again the first step is what? Select the pivot element. I select the pivot element. Then after that start left scan. Generally left scan we are starting next to the pivot element, position I. Now during left scan we are looking for what? Lesser element. Ith element is lesser than the pivot element. So continue left scan. So again ith element is lesser. No, we stopped. After stopping this one, we need to start right scan. Right scan we are starting from the last end. Here this is the last position of this subarray. Now during right scan we are looking for greater. Now this jth element is greater than the pivot element. So continue right scan. Continue right scan. Now jth element is greater than the pivot element. No, we stopped. After stopping both, we need to check I and j. Here now see again. I here, j here. See, I crossed over there j, or j value is 2, j value is 1, I value is 2. So I is greater than j. If I is greater than j, swap what and what? Jth and pivot element. Jth element is 1, pivot element is 2. So 2 comes here, 1 goes here, 3 comes here. Now if you observe now, see this is my pivot element. Towards its left, all other elements are lesser than the pivot element. Towards its right, all are greater than it. This is what the principle of this one. So now, since this is only one element, no need to split again. Okay, we'll stop here only. Now again, we will take what? Right subarray. Right subarray is what? 6, 8, 8, 7 in this example. Okay, now what we are doing? So again, we will take what? First element as what? Pivot element. So generally, we are taking first element as a pivot element. After that, we are starting the left scan. From the next position of the pivot element, I will start in left scan. During left scan, we are looking for what? Lesser element. Ith element is lesser than this. No, we stopped here only. After that, we started right scan. So right scan, we are starting from the last position. During right scan, we are looking for what? Greater element. Jth element is greater than the pivot element. Yes, you continue this. Now again, jth element is greater. Yes, continue right scanning. Jth element is greater than. Yes, continue. Now jth element is 6. Pivot element is also 6. So this is greater. No, it is equal. Even though if it is equal also, we need to stop this. So I stopped jth element. Okay, right scan. After stopping, check I and j. See now I and j crossed each other. Or I is greater than the j. See, I is ahead of j. So we need to swap what? Jth and pivot element. Here jth element is 6 and pivot element is also 6. So I am swapping 6 with 6 only. So I got 6, 8, 8, 7. So here this is my what pivot element we selected, and towards its right I got only all the elements greater than the pivot element. Here in this example, I didn't get what? Left subarray. That means now if you observe this one, we divided into here 2 subarrays, but this one I divided into only what? Right subarray. There is no left subarray. Okay. Now again, we need to take only this one, 8, 8, 7. Again, what is the first step? Select the pivot element. That is the first element. And then we need to start left scan. Left scan, we started here. Now, during left scan, we are looking for what? Lesser element. So whether it is lesser element, no, it is equal. We stop. After that, we have to start right scan. Right scan, we need to start from the last element. Now, during right scan, we are looking for what? Greater element. Whether it is greater element, no, it is lesser. We stop. After stopping, we need to check I and j. See, I is still behind j. That means I value is 6, j is 7. So this I is less than j. If I is less than j, we need to swap ith and jth element. Ith and jth element is this 7 and 8 will swap this 8 as it is. Okay. So this is what our pivot element. So now again, earlier we stopped left scan here. Again, we'll check. So during left scan, we are looking for lesser element. Ith element is lesser. True. So what we'll do, we'll continue this. Now ith element is lesser. Not lesser, it is equal. Equal also need to stop. I stopped here. Okay. So next, after stopping left scan, we need to start right scan. Right scan, we have to start from the last position. Now during right scan, we are looking for what? Greater element. Jth element is greater than the pivot element? No, it is equal. Even though if it is equal, we need to stop. I stop. Now check I and j. I is less than j, I is greater than j. No, now I and j are pointing to the same element. So that means I is equal to j. Even I is equal to j also, we need to swap what? Jth element with pivot element. So now jth element is this 8 and pivot element is this 8. Now this 8 comes to this position and this 8 goes to this position. Now this is my 7. Okay. So now here this is my what? Pivot element, and towards left of this pivot element, all the elements are lesser than or equal to pivot element according to the basic principle of Quicksort. So now that means when I divided this, I got only what? Only left sub 3 I got, left subarray I got. Now again we need to sort this left subarray, that is 8 and 7. So now among these two elements, so again I am checking, selecting first element as the pivot element, and I am starting left scan. This is left scan. During left scan we are looking for what? Lesser. This is lesser. Continue, but there is no element, so now is beyond this range. Okay, we'll stop. After that, we start right scan. During right scan, we are checking what? Greater element, but is greater? No, it is smaller. We stopped here. After stopping both the scans, check I and J. We swap. So since here I is crossed over the J, our I value is, see, this value is what? 5 and this is 6. So I is 7. 7 is greater than the 6. So we need to swap jth and pivot element. So jth element is 7, pivot element is 8. So I am swapping these two, 7 and 8. So here I got, this is my pivot element, and towards left of this I got all are lesser than that. Okay, now if you observe, see, if you observe, finally at the position 0 what we are having? Finally we are having 1. At the position 1 what we are having? 2. At position 2 we are having finally what? 3. At position 3 we are having finally for what? 5. At position 4 finally we are having what? 6. So at position 5, 7, at position 6, 8, and at position 7, 8. Okay. So thus the elements are sorted. Okay. Now let us write algorithm for the same. So for algorithm, so I will write quicksort name, quicksort parameter to be passed is what? L to R, A of L to R. So earlier I am using A of 0 to n minus 1. At that time we know exactly how many number of elements. But here I know only initially I know. But after that where I will get splitted exactly we don't know. Okay, so here 0 to 2, here 0 to 7, here 4 to 7, here 0 to 0, here 2 to 2, here 4 to 7, here 5 to 7, here 5 to 6, like that it keeps changing. So what I am taking, here I am taking leftmost index. Okay, leftmost, next to rightmost index in general. So initially leftmost index is 0, rightmost index is the last element in minus 1th element position. Okay, so this is what the initial setup. Now, what we did first, okay, now this, how many elements are there? More than one elements are there. We split it into two subarrays. Again, when this subarray, we are having more than one element, we split it. More than one element, we split it. More than one element we splitted, more than one element we splitted. But if whether we splitted this one, no. Why? Because only one element. We splitted this one, no. See, this one, and as well as this one we not splitted. Why? Because only one element. If there is only one element, we are not splitting. So now we need to check when to split, when not to split. When we are splitting, when more than one element are there in the array or the subarrays, we need to split. So for that, see, if you check, in this case, this is L and R. L is less than R, true. Here, see, check, this is my L, this is my R. Here also L is less than R, that means more than one element. Here also L, this is leftmost index, this is the rightmost index. Here also L is less than R, more than one element. So if you check here, this is my leftmost index, this is rightmost index. L is less than R, again more than one elements. Again here, this is my leftmost index, rightmost index. Here also more than one element. If here this one is the leftmost and this one is the rightmost, this is equal. Equal means only one element. That means when L is less than R indicates more than one element, at that time it will split. So I am checking the condition. If L is less than R, then what we have to do? Then we need to split. For splitting, I am calling one more function called partition. Okay, in the partition, I am splitting the given array. I am splitting. So once it will split, what I will get? I will get one split position. That is the way we are splitting this array. So output of this partition is the split position. So it is returning what? One split position. Now split it. Now we need to again partition this one. So again I will call the same function. Okay, so this person is doing splitting. So again I splitted this one. Again I need to split this one. So again I call the same person to do split. Okay, quick underscore sort. So now we need to split what? Now the same subarray, but left to this left to what? This is S to previous means S minus 1. So L to what? S minus 1. So this is what? This is S. Its previous position is S minus 1. So next this is over. Next this one we need to split. So for this, where to where? From next to the split position, then R. Next to split position is S plus 1. So again I am calling this function only quick underscore sort A of split position plus 1 to R. Okay, so that's it, this algorithm. And if, okay, so now this is the algorithm only, it is calling one more algorithm, partition. So it will decide when to partition, when not. That's it. If L is less than R, that means if more than one element, then only it is partitioning. Otherwise not. But how to do partition? For that we need to write one more algorithm. Now, so for partition, now I'll write the algorithm. Partition. So what we are partitioning? The array or the subarray, which is generally running from what? L to R. So now, what is the first step we did? We choose the pivot element. Which element we took the pivot element? So generally taking variable P. So which element we selected the pivot element? First element. See, first element selected. First element we selected. First element we selected. First element we selected. So here, first element we selected. Always we are selecting the first element. Which is the first element? A of L. Always A of L is the first element. So that element, A of L. Okay. This statement is nothing but what? Selecting the pivot element. That is first element we select as a pivot element. After that what we did? We took one index I for left scan. So I, from where we started I, see generally here we started I in front of left. See, I took, this is the pivot element, friend, okay. This is my pivot element in front of this one. Okay, this is my pivot element in front of. So in front of pivot element, that means L plus 1 position. But algorithmic, I am writing L only. That means in this position only I am starting. I will tell you why. Okay. Next, we took J index for what? Right index, right scan. So J right scan we are starting from the last position. Last position we starting. See, last position J we started. See, last position we started. Last position we started. Last position we started. But in algorithmic, instead of starting from the last, I'll start from the last, but next to the last. Okay, that means R plus 1. So I will tell again why. This will came to know in a few minutes. Okay. So now we need to start. Now what we did, so during left scan, we keep, see, if it is lesser than element, we incremented I. Again, if it is lesser than element, we incremented. Like this, we keep incrementing the I. That means we are repeating, incrementing I as long as we find lesser element. Whenever we find greater element, we stop. I will repeat. During left scan, we repeating, incrementing I until I find what? Greater than element. Same thing I will write now. Okay. Repeat what? Repeat what we repeated? I incrementing until what? A of I greater than or equal to pivot element. Okay. So where I started from I, L. That means in this position I started, but actually we started here. But here an algorithm I started here. But what do we return? Repeat I. That means first do this, then check the condition. Do this means what? Do this means first incrementing. So I started from left. Incrementing means here only it goes. Here only we started. That means this and this both are same. Okay. Similarly, during the right scan, what we did, see, we keep decrementing the J, greater element, we come to this one, greater element, come to this one, greater element, come to this one. Like this, J, we keep decrementing. That means we're repeating, decrementing J until we find what? Lesser than element. So same thing, we'll write. Okay. So repeat what? J decrementing until what? A of J less than or equal to pivot element. See, this statement is do well, it will indicate left scan. So this statement is doing what? Right scan. Now actually, after stopping both the scans, we need to check I and J. That means till that, if I is less than J, what? I keep repeating. So that means I need to keep repeat these two as long as I is less than J. I should stop this whenever I find I is greater than J. So that means these things I need to repeat until what? Until I greater than or equal to J. Is lesser than, again we keep repeating. Now, this algorithm, here we are swapping I and J after checking. But here we are swapping A of I and A of J blindly. That means without checking anything, after stopping, immediately we are swapping. So to make this undo or redo that operation, so again we are swapping what? A of I and A of j. Then once it comes out when I is greater than j. When I is greater than j, what to do? We need to swap what? A of j and pivot element. Now, once it splits, what I will get? Split position. That split position is what? See, jth position. See here, this array is splitted at this position. This is the S position. There is nothing but j position, same, j stopped here. Similarly, this array, I splitted at this position. This position is what? Nothing but the jth position. That means jth position is the split position. So I need to return what? J. See, this algorithm return j, that I am storing as a split position. Okay, this is what the algorithm. Hope you people understood. Okay. So let us do analysis of this algorithm. So analysis, first step is what? Identifying the problem size. What is the problem size here? The number of elements to be sorted. Okay, that's the problem size. Next step is what? We need to identify the basic operation. Here, which is the basic operation? See here, actually what we are doing, so we are selecting one item and based on that one item, we are keeping lesser than element one side, greater than elements on other side. So keeping lesser than elements, we are doing what? Left scan, and for keeping greater than one side, we are doing right scan. So these two are the basic operations. For this algorithm, we are having two operations as basic operation. For all the previous one, we are having only one basic operation, but for this, we are having these two are the basic operations. Okay, so that is done. Next, third one. So here, the number of times the basic operation is executing not only depends on the problem size, but it depends on how we give the input. For the best example, I will say, let us take 1, 2, 3, 4. This is the given array. The given array to be sorted. This is already sorted. Now what? Again, first one, selected the pivot element, and all are greater than, I kept it one set. That means I split it into one time I split it. Next, this is my subarray, 2, 3, 4. Again, I selected once pivot element, and remaining I got one set. Again, this is second time I split it. So next I got 3 and 4. I selected this one, I got. So that means for 4 elements, 3 times I split it. So if you observe, here I am getting only the right subtrees. I didn't get what? Left subtree. So for 4 elements, I got 3. Suppose if it is 5 elements, n minus 1. Okay. That is n minus 1 number of times I need to do the comparison operation. Suppose, now, let us take a decreasing order. 4, 3, 2, 1. In this case, if I select this one, so what happens? So now this will be split into 3, 2, 1. This is my left subarray. This is my pivot element. All the rest elements this side. Now again, 3, 2, 1. So again, if I select this one, I get 3, 2, 1 left subarray. All are lesser than. Again, this is the second time. So again, if I get 2 and 1, so 2 goes here, 1. Okay. So that means again here also 3 times. 4 elements 3 times. So in this time, I am getting only left subtree. I didn't get what? Right subtree. In this case, I am getting only right subtree. We are not getting. That means if we give the elements in either ascending order itself or descending order, then we are getting any one subarray. We are not getting another subarray. Okay. This will be the worst case. So when will the best case? Will be the best case. Let us take example 3, 1, 2, 5, 4. Now, first step is what? Select the pivot element. If I split, what happens? I will get the here and left side, all the elements are lesser than that and all the elements are greater than our one side. See, one time splitted, I got. Next time, see, if a pivot element splits the array exactly into 2 halves, then that will be the best case. See, again here, if you take 1 and 2, so if you take 1, so I got only 1. So this is, see 1, 2. So again we have 5 and 4. So if I select this one, so I get only left subarray. Okay, so 1, 2, 3 times. For 5 elements 3 times. There 4 elements 3 times. So this will be the best case. That means best case occurs when the pivot element splits the array exactly into 2 halves. That will be the best case. If the pivot element splits the array in such a way that any one subarray only we will get, another subarray we won't get, that will be the worst case. So we need to find both worst case and as well as best case we need to find for this problem. Okay. Now we know when the best case occurs, when the worst case occurs. Let us take for the best case. C best of n, that means number of time comparison operations executed in the best case is equal to what? So in the best case it divides into how many parts? 2 parts. So in both the parts almost it is equal, half of, and whenever splitted 1, I am going to start only one element. Only the pivot element is in its final position. So for one time one element sorted, second time one more, third time one more, like that for n items n times. So I write n. Now here we know that value of a is when compared to the what? P of n is equal to a into t of n by b plus f of n. General recurrence equation of divide and conquer technique. So we'll came to that what? A is equal to 2, b is equal to 2, and f of n is equal to n. This can be written as n to the power of d, n to the power of 1 only. So d is equal to 1. So I know a, I know b to the power of d. So a is 2, b to the power of d is 2. These two are equal. So then I can write C best of n belongs to big omega of n to the power of log n to the base b according to the master's theorem. So now if we replace these values, I will get C best of n belongs to big omega of n to the power of 1 log n to the base 2. This is n to the power of n only. So this is my at the best case. Okay. Now for the worst case. Hope you understood for the best case. Now we'll do for the what? Worst case. So the worst case, we know that when the worst case occurs whenever our pivot element splits in such a way that one of the subarray is empty, another subarray is having n minus 1 element. So C worst of n is equal to one side will get 0 elements, C of 0, another element, another side remaining elements will get n minus 1. So this is that plus again every time one element we are sorting, so n element. So we are this 0 elements means we are not at all doing anything. So it is 0. So 0 plus C of n minus 1 plus n. Now you use backward substitution method here. So now function is equal to its previous plus 1. So this C of n is equal to what? C of its previous n minus 2 plus n this n. Okay. So this is C of n minus 2 plus 2n. Similarly, the next term is C of n minus 3 plus 3n. So like that goes on. C of n minus I plus I into n. You call this equation as 1. But we know that what? If only one element is there, we are not doing anything. So we know C of 1 is equal to 0. If one element is there, we are not executing this basic operation. So what we are doing? So we need to bring it to this initial condition. For that, what I will do? I will put what? I is equal to n minus 1 in equation 1. If I put I is equal to n minus 1 in this equation, I will get C worst of n is equal to C of n minus n plus 1 plus n minus 1 into n. So n get cancelled. C of 1 is 0. 0 plus n square minus n. If you multiply n into n square minus n. So out of these terms, this is the most dominating term. So C worst of n belongs to big O of n square. This is the time complexity of Quicksort at the worst case. Hope you people understood. Thanks for watching. So if you have any questions or any doubts, please write in the comments. Thank you.